Welcome to Clark Classroom. Don't forget to subscribe. In this video, I will prove the formula for the area of a circle. Area is equal to pi r squared. In order to follow this proof to its conclusion, you will need to know these three trigonometric identities. The Pythagorean identity, sine squared theta is equal to 1 minus cos squared theta. The half angle formula, cos squared theta is equal to a half plus a half cos 2 theta. And the double angle formula, sine 2 theta is equal to 2 sine theta cos theta. Now direct your attention to this diagram that is sketched here on the left hand side. The circle centered at the origin has equation x squared plus y squared equal to r squared. We are only focused on the top half of this circle. If you solve the equation for y, then we obtain y is equal to the square root of r squared minus x squared, and that's the positive portion of the circle that is above the x-axis. We'll only look at this quadrant, 1/4 of the circle, and whatever value we get for the area of this quadrant, you multiply that by 4 to give the area of the complete circle. That is what we will show right here. Recall that the area under the curve is given by the integral. Area is equal to the integral from a to b of f of x dx, where the region over the closed interval ab is completely above the x-axis. So we set up that integral with f of x equal to the square root of r squared minus x squared. In order to solve this integral, we make the trigonometric substitution x equal to r sine theta. Derivative dx is equal to r cos theta d theta. From the equation x equal r sine theta, we deduce the following. Sine theta is equal to x divided by r. So if sine of theta is equal to x over r, then we can illustrate that in a right triangle, showing that the sine of the angle is equal to the opposite over the hypotenuse, x over r. And from which we get the third side of the triangle by applying the Pythagorean theorem. That will be the square root of r squared minus x squared. Notice here that from sine theta is equal to x over r, we also have theta, which is equal to sine inverse x over r, and cos theta will be equal to the square root of r squared minus x squared over r. These three equations we will need to convert back from theta to x. Making the trigonometric substitution, that is, substituting x equal r sine theta in the integral, we end up with r squared minus r squared sine squared theta, and dx is equal to r cos theta d theta. Notice that we drop the limits of the integral because we have now switched from x to theta. And this simplifies to give us r squared times 1 minus sine squared theta times your r cos theta on the outside there. A further simplification, we replace the 1 minus sine squared theta using that version of the Pythagorean identity. So we end up with r times r. From here, we are going to get cos theta times another cos theta, and r times r gives me r squared, and now we have cos squared theta d theta. And now that's equal to further simplification and making the substitution for cos squared theta right there. We have r squared times 1/2 plus 1/2 cos 2 theta. Again, we move the 1/2 through the integral on the outside, and we can do that since it's a constant, to end up with 1 plus cos 2 theta d theta inside our integral. And then integrating here with respect to theta, that will be theta, and this will be 1/2 sine 2 theta plus the constant of integration there. So now we have r squared over 2 on the outside, theta, and we use the identity for sine 2 theta equal 2 sine theta cos theta right here. Sine 2 theta gets switched to that. 1/2 times 2 cancel out that fraction, and now we have r squared over 2 times, substituting back, theta was equal to sine inverse x over r. Sine theta is equal to x over r, and cos theta was equal to the square root of r squared minus x squared over r. Now that we have make the switch back from theta to x, we can now put back our limits of integration from 0 to r. We continue by substituting the limits into x. And so we have sine inverse r over r would give us sine inverse 1. And r over r would give us 1 there. And r squared minus r squared will give us 0. So this term goes to 0. And now we plug in 0 for x, and we get sine inverse 0. And plug in 0 here for x, that's going to be 0 multiplied by whatever we have there. So this term is also 0. So we're subtracting 0. And now sine inverse 1 is equal to pi over 2. And we are subtracting. That term is going to be 0 plus 0, which is 0. So all we have left is r squared over 2 times pi over 2 equals pi r squared over 4. Now, recall that what we're doing here is only 1/4 of the circle, the quadrant. So to get the area for the entire circle, we would multiply that result by 4 to give us pi r squared. And this concludes the area of the circle formula. If you find this video useful, please subscribe to this channel, and I welcome your comments and or suggestions.